Hi everyone, good day. Welcome back to our next video. In this video, we will understand about the flow control statements and in particular about the conditional branching statement. Let us move on to the video. In a C program, the flow of control can be either sequential, selection or looping. In sequential flow control, the program control flows sequentially from top to bottom. That is, the statements here in sequential flow control are executed one after another. Say for example, this flowchart explains a sequential control. Here we do not have any change in the flow of control. When we start from the beginning, it goes straight to the end. Start, so first we have the start, then we are reading two variables A and B. The next statement executes the next statement where we are processing. We are adding the two numbers A and B. Then we go to the next statement where we are printing the value of C, which we have already computed as A plus B. Then finally we come to the end of the program. So this is sequential flow. So here we did not skip any statements. We started executing from the first statement till the end. Next is the selection. The selection statements are also called as branching statements or decision-making statements. Here in selection, it selects the flow of control based on a condition. You can see the example. So it is not like the sequential flow. So we are having a condition if A is greater than B. So based on that condition only, the next set of statements will be executed. Suppose if A is greater than B, then it will go and execute the true block. It will print A. It will skip print B. If A is greater than B becomes false, then it will go to the print B block. It will print B. It will go to that flow. So here we can see based on this decision, the flow of control is changing. So this type of flow control we call it as selection flow control. Next is the looping flow control. So when we want some set of statements to be executed again and again, that is repetitive execution of some certain task is required, then we go for looping or otherwise called as the iterative statements. So see the example here. So we are printing the value of x starting from 0. So initially we are giving the value as 0 and we are having a condition and we are checking whether it is less than 10. Suppose the x value is less than 10, you print the value of x. Again you increment the value of x. The loop is continued. The same task is going to be repeated again till the x value is equal to 9. So when the x value becomes 10, the condition becomes false here and it will come out of this loop. So this repetitive task is terminated and it will come out of the loop. So when you want to perform such repetitive task or when you want to repeat certain task again and again, we go for the looping flow of control. Let us discuss about the branching statements. Branching statements are used to transfer the program flow control from one point to another. There are two types of branching, conditional branching and unconditional branching. In conditional branching, program control is transferred from one point to another based upon the outcome of a certain condition. If the condition is true, it will go to one set of statements. If the condition is false, then the flow control will go to another set of statements. Conditional branching, we normally call it as selection. So the selection statements available in C are if statement, if else, if ladder, nested if and switch. So by using these statements in C program, we can do the conditional branching. In unconditional branching, program flow control is transferred from one point to another without checking any condition. It doesn't check any condition, just when we use the jump statements, it will go to that location directly. So unconditional branching or otherwise called as the jump statements. The jump statements available in C are go to statement, break statement, continue statement and return statement. In this video, we will learn in detail about the conditional branching. In order to perform conditional branching, the selection statements available are if statement, if else statement and switch statement. So we also have variations of if ladder and nested if. So let us start a discussion with the simple if statement. So the syntax for simple if, we give the keyword if followed by the condition. So based on this condition only we are changing the flow control. Followed by the if header, you will be having the block of statements for the particular if statement. If you have more than one statement, it has to be enclosed within curly brackets. If there is only a single statement, then we need not put the curly bracket, just the statement itself is sufficient. The flowchart explains the flow in a simple if statement. So we check the if condition. The condition is evaluated. If it evaluates to true, the statement constituting the if body is executed. If it evaluates to false, the if body is skipped and the statement next to the if body is executed. Next is the if else statement. The syntax for if else, if followed by the condition. If it is true, it will go to the if block, so enclosed within curly brackets. If the condition is false, it will go to the else block, enclosed within the curly bracket. We can see the flow chart. So if the condition is evaluated, if it is true, the statement in the if body is executed and the else part is skipped. If it is false, the if body is skipped and the else body is executed. The else statement cannot be used without the if statement. Multiple else statements can't be used with one if statement. After the execution of the if part or the else part, the execution will continue from the statement following the if else statement. When a series of many conditions have to be checked, the else if ladder can be used. So the syntax for else if, so it is similar to our if else syntax, but it will continue like a ladder. So that is why we are saying it as a else if ladder. So if condition 1, if it is true, it will go to the statement 1. False means it will go to the next else if block. Again, we have to check for the condition, second condition, because we have a series of conditions that needs to be checked. So if the condition is true, it will go to statement 2. Otherwise, it will go to the next else block where we have the next condition. So how many other conditions we need to check? So if we can do that by using the else if ladder. So first, let us see one example for if statement. Give the comment section. Check positive number. So this is for a simple if statement. This program is for a simple if statement. Include the header file. As we will be using input-output functions, we are including the header file stdio.h. Then we are putting the set of statements inside the main function. So to check a positive number, we need to read a number. So we are declaring an integer variable. By using the input statement scanf, we are reading the number n. We are giving %d as a format specifier because the variable is a integer. Ampersand n. In address of n, we read the value of n. So we are using a simple if. We are checking the condition whether n is greater than 0 because this program is to check whether it is a positive number. So we are checking whether n is greater than 0. If the condition is true, it will print %d is a positive number. So in the place of %d, the number will be displayed. Whatever number we are taking as input in the standard input will be displayed. So if you want to give curly brackets, we can give the if block can be enclosed within a curly bracket. If it is only a single statement, then it is not necessary. So after the if statement, we are giving another statement to see the flow of control. So here the statement displays exit from the program. The escape sequence /n is given so that the exit from the program will go to the new line. So we are giving the input in the standard in 46, which is a positive number. So run the program. Since it's a positive number, you will get 46 is a positive number. So after the if block, the program control goes to the next statement after the if block. Exit from the program. Now I am changing the number to negative -46. run the program. It will just print exit from the program. Because in if condition we have checked n is greater than 0, the condition is false. So it will skip the if block and will go to the next statement after the if block. The next example is for if else statement. We will check whether the given number is positive or negative. The same program we will modify. We will include the else block in the same program itself. So instead of the last statement, we give the else block. So if n is greater than 0, it will print it is a positive number. The number is a positive number. Else, it will print it is a negative number. So we will be inputting a number and we'll check whether that number is a positive number with the condition if n is greater than 0. Else, it will go to the else part, it will print it is a negative number. So as it is only a single statement, I am removing the block. The input can be given in the standard IN 34. Run the program. You will get it is a positive number. 34 is a positive number. So the control goes to the if block. As it is true, the condition is true. If we make the number as negative, if n greater than 0 condition becomes false, it will go to the else block. Minus 34 is a negative number. So next, let us modify the same program for else if ladder. We'll check whether the given number is a positive number or negative number or 0. So the same program can be modified. So you need to add one more condition. Else if n is less than 0. So first it will check whether n is greater than 0. It is a positive number. Else if n is less than 0, the given number is a negative number. Else, you will print it is 0. The input can be given in the standard IN. So we are giving the input as 12. It will print first condition is satisfied. So it will print it is a 12 is a positive number. Then we will give a negative number minus 12. So first condition it will skip the first block. It will go to the next block. It will print minus 12 is a negative number. If you give 0, it will go to the last else. First if condition is not satisfied. Second condition is also not satisfied. So by default it will print the last else block. It is 0. Next is the nested if. If within any if block or else block, if you want to check for a condition, again we can use another if else statement within that if block or else block. So this type of statements we call it as a nested if. If within another if, we can embed a if else statement within another if statement, we call it as a nested if. So the syntax, we have the if statement followed by the condition. Inside the if block, we can see we have another if else for checking the another condition, condition 2. So for the first if block, we have to give the corresponding else block. So inside this else block also, we can have if else statement. Next is the switch statement. It is a multi-way branch statement. When there are many conditions, it becomes complicated to use if-else constructs. In such cases, switch statements are used, which provides way to select among multiple operations. The syntax for switch, we have switch statement followed by the expression. This expression can be integer or character. Within the switch block, we have the case blocks, where the case block will be selected based on the expressions. So we have the case blocks followed by the labels for each case block. So label 1, label 2, etc. We can have any number of labels up to label n. So these labels are known as the case labels. They can be either an integer constant or a character constant. The value of the labels should be unique. That is, no two case labels should have or evaluate to the same value. We can have one default statement within the switch body. So this is optional. In a switch statement, the switch selection expression is evaluated. Then the result is compared with the switch labels. And whichever case matches, that block will be executed. If no match is found, the default block will be executed. If no default block is available and no case matches, the control comes out of the switch body and executes the statement after the switch block. If a case matches, then execution continues on into the next case also if break is not given. If you don't give a break statement, the execution will continue to the next case also. So to avoid that, a break statement has to be given inside all the case block. Let's see one example for the switch statement. So a program to display the remarks based on the grade given. First give the comment section, display remarks based on grade, header file for standard I/O functions, then the set of statements enclosed within the main functions. So we are going to give the case label as a character constant. So reading a character variable, declare the variable grade as a character, read it by using the scanf statement from the standard I/O. Switch statement. So the switch expression is grade. Here we are passing a character value here. So whichever character value we are passing, based on that, the case label will be selected. So case yes. Within this case block, I'm giving the remark as if the grade is yes, printf excellent. So we have to use the break statement, otherwise it will continue to the next case if you do not use the break. So next case is case C. So if the character what I am reading is C, grade C, then I will print satisfactory. Include the break statement. So you can include any number of case. So here I have not included all the case. So you can also include A, B. So finally the default case. So if any of the character what we are giving does not match the case labels, then it will automatically go to the default case. It will print grade does not match. So let us give the input. So in the standard IN, suppose if I give the character as yes, it will match to the first case, cases, it will print excellent. Excellent is displayed. Suppose if I give C, it will go to the case C, it will skip case yes and will go to case C, it will print satisfactory. Suppose if I give a case which is not available in the switch block, say for example A, it will print. Finally, it will go to the default case and it will print grade does not match. Suppose if I do not use a break statement and if I give the case as yes, you can see we will get excellent. It will also go to the next case and it will print satisfactory. So if I want satisfactory in a new line, you include the escape sequence /n. So it will be displayed in the new line. Excellent, satisfactory. Same thing, if I comment the break statement in case C also. Now if I give yes also, the first case will be executed. It will execute the second case and it will also execute the default case. It will go till where it has a break statement. So excellent is also displayed, satisfactory is also displayed, grade does not match is also displayed. So that is why break statement is very, very important inside the case block. So this is an example for the switch statement. In this video, we discussed about the conditional branching statements. The next video will discuss about the unconditional branching statements. Hope this video was useful to you. Please don't forget to subscribe, like and share. We will meet in the next video. Thank you.